is being recorded now. Okay, so let us take a problem which we have already done. Okay, so let us take this one as, if you remember, we did a problem like this. This was the same element. Here it was fixed, here also it was fixed, and we had a UTL over here, and this one was 6 tons per meter, and the length of this member is 4 meters. This one is of length 3 meters. This is 3i. This is 2i. This one is again 3i. Okay, you please check your notes. We have already done this one. I am only focusing now on the shear force, bending moment, and how you are supposed to calculate the reactions for this one. Okay, so you can refer your notes. You can find all the procedures there. Okay, so let me write the end moments. Okay, so final end moments are the final end moments are MAB equals to 1.558 transmitter. Please someone verify this one. We have done this problem. MBA equals, this is using slope deflection method. Problem of slope deflection method.
Yes, sir. Correct, sir. Maybe.
Method. Okay. MBA is 3.116 ton meters. Then MBC equals to MBC is coming minus 3.6 ton meters. Then MCB equals to plus 3.116 ton meters, and MCB equals to minus 3.116 ton meter. MDC equals to minus 1.558 ton meter. Okay, so these are the end moments which we got. Okay, this is, so what is the step number? What is the step number? Step number 4 or step number 3? 4. Okay, so now the next thing is we need to find out the reactions, and then we will go for the shear force and bending moment diagram. Okay, so let us take, okay, let me give the number. So this is A, this is
Yes,
B.
sir.
Yes.
Sir, could you mention that points are A, B, C, D?
Yes, I'm mentioning A. Node A is this one, node B is this one, node C, this is node D.
Sir, thank you.
Okay. So let's take AB, AB, or let us take first BC. Okay, BC. Okay, So I'm writing here, this is step 5, reactions. Okay, so let us take first span BC. Span BC. So if I consider this span BC, you can see here at node B it is rested, at node C it also rests. So it means that there is what? There is a vertical force in this direction and another vertical force in this direction. So if you draw the free body diagram, so let us say this is the span, this is one vertical reaction, this is one another one, this is B, this is C, and this is RBC, for example, and this is RCB. Okay. Now, what about the moment? You can tell. What about the moment? Moment will be, one will be in this direction, that is how much? 3.116, and another one will be in this direction, and this will be again 3.116. So you can see this is 3.116, this is also 3.116. Their sign is different, means if one is clockwise, another one is anti-clockwise. Okay, so let us find out the reactions RBC. Okay, we all know that this span is how much? 3 meters. Okay, so let us take moment across B. This we already know that this is joint B, this is joint C. So taking moment across B. So if we take moment across B, then RCB into 3 plus this one 3.116, then minus this one 3.116, then what about this one? So it will be minus W. This, how much is the W? It is 6 tons per meter. So what will be the formula? WL by or WL square by
2DL sir, WL square by 2.
WL square by 2, right?
Yes sir.
6 into T square divided by 2 equals to 0. Okay, so this positive and this minus cancels out. Okay, so the leftover thing is this implies RCB equals to 6
9
into
ton.
T
Sir.
square into 3. So it is 9 ton. So if RCB equals to 9 ton, then how we will determine RBC?
Total load. Total load.
Yes, so that is
R
summation of Fy equals to 0. This implies RBC plus RCB equals to W into
W into 6. 3 sir.
W
3.
into 6 into 3. Okay, so this implies RBC equals to 6 is 18 minus
9.
9. So it is 9 tons. So this implies RBC equals to 9 tons. Okay. Understood? Now, if, okay, now, since this is UDL, where will be the maximum bending moment?
At midspan, sir.
At center.
At 1.5 meters.
Sure, huh?
Yes, sir.
Yeah. That's fine. Yes, sir. Sure, sir.
Sure. Okay. So now let us take the column AB. Okay. Let us take the column AB. This is column AB. If we take the column AB, it is like this, and here we will have a horizontal force, that is A, and here we will have one resisting force, and here already the moment is 3.116, and here the moment is 1.558. Okay, and the distance between this is A, this is B, and the distance between A and B is, how much is the distance between A and B?
4 meters, sir.
Okay, so now can we find out HA? Can we find out this HA? Because
Yes, sir.
here we don't have any vertical reaction. Well, can we find out HA? So can I write HA? Or if I take moment about, if I take moment about B, okay, let's write that one in terms of moment. Taking moment about B. Taking moment about B, we have H into 4, then minus 3.116. Then what about this one? This is making what kind of movement, whether it is clockwise or anti-clockwise?
Both are in clockwise, sir.
Both are in clockwise, yes. So it is minus,
Yes, sir.
again 1.558 equals to 0. This implies HA equals to 3.116 plus 1.558 divided by 4. How much is this one? Please calculate.
1.168, sir.
0.16.
8 ton.
Okay. Now let us take the column, that is CD. Okay. Let us take the column CD. Okay. So just like the previous column AB, here also just like HA, we will have one horizontal force, and that is HB. Okay, this will we are taking that HB will resist HA. Okay, and the next one is, here we are having again a moment, that is 1.55 feet, and the other moment is 3.11. Okay, again the distance between C and D is 4 meters. Am I correct? Is it 4 meters? Yes or no? Yes or no? Tell me.
4 meters only, sir.
Hmm?
4 meters, sir.
Yes, it is 4 meters. So similarly, we, we take, okay, this is column CD. So if I take moment across C, so taking moment about C, we have H HB into 4, then this is minus 3.115 minus 1.558 equals to 0. So this implies,
Sir,
please all of you mute your mics.
sir,
Yes, Hari Krishna, you wanted to say anything?
sir, what you are writing on the screen is not visible, sir.
మీకు
It will stuck.
కనిపిస్తుంది.
నాకు కనపడట్లేదు కృష్ణ మధ్యలో స్టక్ అయిపోయింది కాలం ఏబి దగ్గర.
Okay, you don't so you don't worry, I am recording this one, so you will get this. Okay, don't worry, I am recording everything. Okay, so this implies HB equals to 3.115 plus 1.558 divided by 4, that is again coming to be 1 point, is it correct? 1.168. Okay, now next one
Sir.
is free body diagram. Okay, so now we will draw the free body diagram, then we will go for the shear force SFD and DMD. Okay, now let us see. Please all of you mute your mic because a lot of disturbance is coming in between. Okay, so let us first draw this one. This is the original structure. This is the ton per meter. This is P, this is P, and this is D, this is again it is 4 meters. This is because I need to put the moments and reactions. Okay. Okay. So for the moments, I'm using black. So this is how much? It is 9 tons. This is also 9 tons. And the horizontal reaction equals to HA, how much we got? 1. This is P. Also 1 point.
So your voice is not audible.
Aman, now it will be audible, I guess.
Yes, sir.
Okay. So 1.168, and the next one is any other moments are there we need to show? No. Okay, this one. So these are the reactions. Okay, now if we go to the shear force diagram, okay, so let me draw the SFD. For SFD again I need to show the structure. So here, how much is RAB? How much is RAB? This, let us say this is the structure. Okay. How much is RAB? RAB is 1.558, right? Am I correct? 1.558. So
That is momentum.
sorry. Yes, that one. Moment. Sorry, not RAB. Moment. Okay. So here it will be a constant one. This will be 1 point. Wait. Here it will be 1.558. This is positive, and this one is 9 tons again. This is 9 tons again. This is V. This is A. This is C, and this is D. And here also it will be 9 tons. So this portion, let me show which one is positive. This is positive. This part is again, sorry, this is positive, this is negative. This is negative, and this portion is also negative, whereas this portion over here this one is positive. So this is about the, and this one is also positive, as I said. And please mute your mics. Purisha. The next one.
Sir, one doubt, sir.
Yes.
Sir, how
Bolo.
to take that column width, sir?
Column?
Width,
This is only
this-
1.558. No, this is not column width. This is 1.558. This one is 1.55.
1.5, sir. Okay, sir.
Okay, 1.558. That one.
BC also.
Sir, how
Yes.
can you draw that one, sir? Shear force diagram.
Here we have moments, no?
For movements, we draw shear force diagram, sir.
Wait, let me complete this one, then we will come to know.
Okay, sir.
Okay. Just wait. For the frame, it is a little bit complicated than for the continuous beams and all. Now for the bending moment, this one is this will be, since this is having a UDL, this is 3.116. This is again 3 point, wait, 1.558. This one is 3.116. That is opposite one, and this one is 6.75. Next one, this one is again 3.116. 6. So this part is positive, and this part is also positive. And sorry, this part over here this will be again positive, and this one and this one. This letter is also different.
నైట్ శరత్ నైట్ చలికి
Govardhan, your voice is getting recorded.
Sir, not me, sir. Adi Krishna.
Sorry, Krishna.
సారీ సార్.
So this part will be negative. This part will be again negative, the opposite ones. Okay. And this will be positive. So it will be like this. Okay. So now we'll take another problem. Let me see which problem we can take. So likewise, you need to plot the shear force and bending moment diagrams for the different frame members. Okay, and so in the previous class, which problem we were doing?
సార్ వన్ డౌట్.
Yes.
6.75 where we get, sir?
Huh?
Maximum 6.75
For UDL?
maximum, sir. Maximum bending moment.
WL square by 8.
WL square by, what is the
8.
formula to get the maximum bending moment for each?
WL square by 8.
Yes, you compute that, how much it is coming?
6.75. Okay, sir.
Okay, na?
Okay, sir. Sir, 1.58 we take column width, sir.
No, not column width.
MAB moment, sir.
That one is moment. It is not column width. I don't know why you are always asking, sir, how much is that column width? How much is that column width? That is the moment which we are plotting.
Yes, sir.
Okay. Again, electricity is going on here. Okay. So the next problem we can have is, shall we start a new problem with that moment distribution method? Because in the previous class we have solved for the moment distribution of a frame which was having a overhang, sorry, not frame, a continuous beam which was having a overhang, and that too one support was sinking. Okay, so let us start for a frame. So let me stop the recording. Again, after that I will record. I'll stop it here.